In today's video, I am going to show you how to simplify rational expressions. Before we dive into simplifying rational expressions, let's refresh our memory on the operations of fractions, because a rational expression is just a fraction with polynomials in the numerator and denominator. So let's see. On example 1, it says simplify. I have the fraction 6 divided by 9. To reduce this fraction, I can divide both the numerator and the denominator by 3, which would give me 2/3. To multiply fractions, you multiply straight across. 1 times 8 is 8, and 4 times 3 is 12. I can reduce this fraction by dividing both top and bottom by 4, and that will also give me 2/3. To divide fractions, you keep the first fraction the same. You change the division to multiplication, and you flip the second fraction. 3 times 5 is 15, and 4 times 4 is 16. My answer is 15/16. To add or subtract fractions, you need a common denominator. Right now, I do not have a common denominator on example 4, but I can get a common denominator by multiplying this first fraction by 2. 2 times 2 is 4, and 2 times 3 is 6. So now I have 4/6 plus 5/6. Now that I have a common denominator of 6, I can add my fractions. I'm going to keep my common denominator the same, and I'm going to add my numerators. 4 plus 5 is 9. You always want to reduce when you can, and I can reduce this fraction by dividing it top and bottom by 3, giving me 3/2. Now, improper fractions are not a bad thing. In Algebra 2 and higher, we love improper fractions. They're great. There is no need to change these into mixed numbers. Improper fractions are just fine. On example 5, I need a common denominator to be able to subtract these two fractions. Because my denominators are not multiples of each other, I will need to multiply both of them. The least common multiple of 2 and 9 is 18. So I'll have to multiply 1/2 by 9 over 9 and 5/9 by 2 over 2. So 9 times 1 is 9, and 2 times 9 is 18. 5 times 2 is 10, and 9 times 2 is 18. Now that I have a common denominator, I can subtract my numerators. 9 minus 10 is -1, and that's going to be over 18. Go ahead and pause the video and see if you can try the second row on your own. On number 6, I can reduce this by dividing both my numerator and denominator by 5. So I am going to get 6/7 as my answer. To multiply, you multiply straight across. 2 times 7 is 14, and 5 times 8 is 40. I can reduce this by dividing both top and bottom by 2, and that is going to give me the answer of 7/20. To divide, I'm going to keep the first fraction. I'm going to change division to multiplication, and I'm going to flip the second fraction. 5 times 3 is 15. 2 times 1 is 2. My answer is 15/2. I need a common denominator in order to add 1/4 plus 9/10, and my least common multiple is going to be 20. So I can multiply this first one by 5 and this second one by 2. 5 times 1 is 5. 5 times 4 is 20. 9 times 2 is 18, and 10 times 2 is 20. 5 plus 18 is 23. So my answer is 23/20. On number 10, I need a common denominator in order to subtract. My least common multiple here will be 24. So I'm going to have to multiply this first one by 3 and the second one by 8. So I'm going to have 27/24 minus 32/24. My common denominator is 24. 27 minus 32 is -5. So my answer is -5/24. Now that we've refreshed our memory on how to do operations with fractions, we're going to apply these same rules and concepts to rational expressions. So, a rational expression is a quotient of two polynomials. The domain is all real numbers except those for which the denominator is equal to 0. Down here we have 4 examples of rational expressions. You can see that they are just fractions that have polynomials in the numerator and the denominator. To simplify rational expressions, look for factors that are equivalent to 1. Just like how 2 divided by 2 is 1 or 10 divided by 10 is 1, x divided by x is 1, and 2x plus 5 divided by 2x plus 5 is 1. To find excluded values, these would be your domain restrictions. Set the denominator equal to 0 and solve. So these are numbers that would make our denominator 0. And we do not know how to divide by 0. And so we need to exclude these values from our domain. Let's look and try example 1. Example 1 says write an expression that is equivalent to x cubed minus 5x squared minus 24x divided by x cubed plus x squared minus 72x. So the first thing that you always want to do, just like how it says here, is to factor. Whenever you're factoring, your first step is to always look for a GCF. I have a GCF of x in my numerator. So I'm going to have x squared minus 5x minus 24 inside parentheses. In my denominator, I also have a GCF of x. Left inside my parentheses will be x squared plus x minus 72. Now we always want to factor completely. So when I look at this fraction, x is already factored completely. This x right here. It's a linear factor. It's as simplified as it's going to get. But I can factor x squared minus 5x minus 24 some more. It's a quadratic trinomial, and so I can factor that whichever way that you like best for factoring. I'm going to use the area model. So you always want to multiply your first number by your last number. Here I'll get negative 24. So that means that I'm looking for factors of negative 24 that add to negative 5. Those factors are negative 8x and positive 3x. In my top row, my greatest common factor is x. In the bottom row, my greatest common factor is 3. In the left column, my greatest common factor is x. And in the right column, my greatest common factor is negative 8. So here, this simplifies to x plus 3 times x minus 8. That is my numerator. In my denominator, just like how we said with the numerator, this factor of x is already as simplified as it's going to get. So I'm going to go ahead and leave that there. And then I want to factor this quadratic trinomial completely. So I'm going to do the same thing that I just did in the numerator, and I'm going to go ahead and factor this using the area model. Again, you don't have to use the area model. You can use your favorite method for factoring here. With the area model, you always want to multiply the first number by the last number. So that means that I'm looking for two numbers that multiply to negative 72 and that add to my middle term of 1. And that is going to be negative 8x and positive 9x. So my greatest common factor in my numerator is x. The greatest common factor in my denominator is 9. The greatest common factor of my left column is x. And the greatest common factor in my right column is negative 8. So this simplifies to x plus 9 times x minus 8. Once you have everything factored, that's when you can go ahead and find your domain restrictions. These are your values that x cannot equal because if x equals these values, then you will get 0 in your denominator, and we do not know how to divide by 0. So to figure out your domain restrictions, you're going to set the factors in your denominator equal to 0 and solve. In my denominator right now, I have 3 factors: x, x plus 9, and x minus 8. So I'm going to take each of those 3 factors and set them equal to 0. And then I'm just going to solve each of these equations. X equals 0 is already solved for. For this one, I'm going to subtract 9 on both sides and get x equals negative 9. And over here, I'm going to add 8 to both sides and get x equals 8. So x can equal any number it wants except for these 3 numbers of 0, negative 9, and positive 8. The way that we write that is we use braces. And I'm going to say all values of x such that x does not equal 0, negative 9, and 8. So again, this notation means that your domain, let me write that up. The domain is all real numbers except for 0, negative 9, and positive 8. That is what this right here means. All values of x such that x does not equal 0, negative 9, or 8. So it's always easiest and best to do this once everything is factored. Step 3 is going to have us go back and look at our fraction that we have over here. So it says recognize that the common factors in the numerator and denominator are equal to 1. So what they mean by that is, if you notice, I have a common factor of x in my numerator and denominator. And I have a common factor of x minus 8 over x minus 8 in my numerator and denominator. These factors are equivalent to 1, just like how we set up here. So because I'm multiplying all of this factors together, I can really separate these up into 3 fractions. I could say that I have x over x times x plus 3 over x plus 9 times x minus 8 over x minus 8. This factor right here of x over x is 1. Just like how 2 divided by 2 is 1, or 5 divided by 5 is 1. Times, I can simplify this fraction, so it's just going to stay as x plus 3 over x plus 9. Times, here I have equivalent factors over each other. X minus 8 divided by x minus 8 is 1, just like how 10 divided by 10 is 1. Well, now I have 1 times x plus 3 over x plus 9 times 1. Well, that just means I have x plus 3 over x plus 9. This is a parenthesis. This is my answer. So when you're simplifying, you're going to factor, and then you're going to find your common factors in the numerator and denominator, and you can eliminate them because they're equivalent to 1. That is how you simplify. To find your domain restrictions, you take your factored form of your denominator, you set it equal to 0, and solve. That's what we're going to be doing today. So let's try that again on example 2. It says the simplified form of a rational expression has no common factors other than 1 in the numerator and the denominator. So on example 2, it says simplify and find the excluded values. Again, your excluded values are your domain restrictions. You're going to set the denominator equal to 0 and solve. Just like how we did on step 2 in example 1. So that's for this part right here. Before I get to those excluded values, let's look at our fraction itself. We have x plus 10 divided by x squared minus 100. X plus 10 is a linear factor. There's no GCF. There's nothing that I can simplify there. So I'm going to go ahead and leave it as x plus 10. In my denominator, I have x squared minus 100. This is a difference of two squares. In this first term, x is being squared. And in the second term, 10 is being squared. So remember, a difference of two squares, if you have a squared minus b squared, you can factor that as a plus b times a minus b. Now that my denominator is factored completely, I can go ahead and find my excluded values. So for my excluded values, those are your domain restrictions. I am going to set each of these factors equal to 0 and solve. So I'm going to have, there we go, x plus 10 equals 0 and x minus 10 equals 0. To solve this equation, I'm going to subtract 10 on both sides and get x equals negative 10. For this one, I'll add 10 to both sides and get x equals positive 10. So my excluded values will be all values of x such that x does not equal negative 10 or positive 10. Now that I know what my excluded values are, I can go ahead and continue on with the problem. We have factored everything completely, and so now I'm looking for common factors in my numerator and denominator that I can eliminate because they're equivalent to 1. Well, x plus 10 has a common factor with x plus 10. X plus 10 divided by x plus 10 is 1. So that's going to leave me with 1 over x minus 10 in my denominator. That is my simplified expression. That is my answer. Let's do the same thing on example 3. It says simplify and state the domain. Finding your domain is the same thing as finding your excluded values. In my numerator, I do not have a GCF. I do have 4 terms. We learned how to factor 4 terms by doing factoring by grouping. Now you can do this either using parentheses or you can use the area model. I am going to use the area model. When using the area model, when you have 4 terms, you take each of the 4 terms and you put them in its own box. The greatest common factor of my top row is x squared. The greatest common factor of my bottom row is negative 1. The greatest common factor of the left column is x. And the greatest common factor of the right column is 4. So right now I have x squared minus 1 times x plus 4 in my numerator. In my denominator, I do not have a GCF, but I do have a quadratic trinomial. To factor this, I'm going to use the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. Here I'm looking for factors of negative 4 that add to 3. Those factors are going to be positive 4 and negative 1. So the greatest common factor of my top row is x. The greatest common factor of my bottom row is negative 1. The greatest common factor of my left column is x. And the greatest common factor of my bottom column, or my right column, is 4. So this is going to factor into x minus 1 times x plus 4. Because my denominator is factored completely, this would be a great time to find my domain restrictions. Remember, your domain restrictions are the same thing as your excluded values. To find your excluded values, you're going to take each factor in your denominator and you're going to set them equal to 0. So I'm going to have x minus 1 equals 0 and x plus 4 equals 0. To undo subtraction, I'm going to do addition and get x equals 1. To undo subtraction, I did addition. To undo addition, I'm going to do subtraction and get x equals -4. So here my domain will be all values of x such that x does not equal +1 or -4. Now that I have our domain, I can go ahead and continue to simplify this rational expression. We said that our denominator was factored completely, so I'm going to go ahead and write that down. We have x minus 1 times x plus 4. In my numerator, I can still factor this x squared minus 1. I know that because I know that this is a difference of two squares. In this binomial, x is being squared and 1 is being squared. And then x plus 4 is already factored completely. Now that both our numerator and our denominator are factored completely, we can look for common factors in our numerator and denominator to eliminate because they're equivalent to 1. X plus 1 does not have a common factor in my denominator. X minus 1 has a common factor with x minus 1. And x plus 4 has a common factor with x plus 4. So in my fraction here, all I have left is x plus 1 in my numerator. And because both of these canceled out, all I'm left with in my denominator is 1. X plus 1 divided by 1 is just x plus 1. So my simplified form of this expression is x plus 1. That is my answer. So in those first three examples, we were simplifying, which is just like reducing a fraction, like how we did on examples 1 and 6 in our just-in-time review of fractions. When I look at examples 4 and 5, here we are multiplying. So what you're going to want to do is factor first, and then you can eliminate common factors that are equivalent to 1. When I look at example 4, everything is already factored for us. So let's look for common factors. X plus 2 has a common factor with x plus 2, so those can eliminate because they're equivalent to 1. And then x minus 1 has a common factor with x minus 1, so those can eliminate because they're equivalent to 1. All that's left in my numerator is x minus 3. All that's left in my denominator is x plus 5. So my answer is x minus 3 over x plus 5. There's nothing else that you need to do on this one. They didn't ask for domain or excluded values, so this is all we had to do. On example 5, it says find the simplified form and state the domain. I am just going to take this one piece at a time. 5x is already as simplified as it's going to get. So I'm going to go ahead and leave that one the way that it is. X plus 3 cannot be factored. So I'm going to go ahead and leave that one. X squared plus x minus 6. There is no GCF here, but it is a quadratic trinomial. Excuse me. So I am going to factor that using the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. Here I'm looking for factors of -6 that add to 1. Those factors are 3x and -2x. The greatest common factor in my top row is x. The greatest common factor in my bottom row is -2. The greatest common factor in my left column is x. The greatest common factor in my right column is 3. So this is going to be x minus 2 times x plus 3. In my denominator, I have x squared plus 2x minus 1. There is no GCF here, but I can factor it using the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. So here I'm looking for factors of 1 that add to 2. Those factors are 1 and 1. In my top row, my greatest common factor is x. In the bottom row, my greatest common factor is 1. In the left column, my greatest common factor is x. And in the right column, my greatest common factor is 1. So here I'm going to have x plus 1 times x plus 1. For this numerator, I do have a GCF. Here my GCF is x, and left inside parentheses I'll have x plus 1. In my denominator, I have 5x minus 10. Here I also have a GCF of 5, and I'll have x minus 2 left in parentheses. Now that I have factored everything completely, I can look for common factors that are equivalent to 1. Before I do that, they did ask us to state our domain. So I am going to do that first while everything is nice and neat and factored here. So my domain restrictions are going to be when I set my denominator equal to 0 and solve. So I'm going to have x plus 3 equals 0, x plus 1 equals 0. Notice how x plus 1 happens twice. We only have to solve it once. It will give us the same restriction. My next factor is 5, so I'll have 5 equals 0, and x minus 2 equals 0. So let's solve each of these. To undo addition, I'll do subtraction and get x equals negative 3. To undo addition, I'll do subtraction and get x equals negative 1. There's no variable to solve for here. So when this happens, you're looking to see if you have a true or a false statement. Does 5 equal 0? No, it's a false statement, and so it doesn't affect anything. If you were to have a true statement, then all real numbers would be your excluded values. And then for this last equation, to undo subtraction, I'll do addition and get x equals 2. So my domain will be all values of x such that x does not equal negative 3, negative 1, or positive 2. Now that we have found our domain restrictions, I can go ahead and start eliminating factors that are equivalent to 1. So 5 has a common factor with 5. Let's see what else. X minus 2 does not have a common factor. X plus 3 has a common factor with x plus 3. Oh, we used green. Let's use blue. Oh, we already used blue. I'm running out of colors. Let's see. X plus 1 has a common factor with x plus 1. So let's see what we have left. Let's use this color right here. In my numerator, I have x times x. X times x is x squared. In my denominator, I have, oops, we forgot one. Here, x minus 2 eliminates with x minus 2. So all I have left in my numerator is x plus 1. This is the simplified form. I cannot simplify any more than this. This is my answer. Now that we've gone over reducing, which is the same thing as simplifying, multiplying, now let's go over dividing. So example 6 says find the quotient and state the domain. To find a quotient, you're going to do the same thing that we did with fractions. You're going to keep this first fraction the same. You're going to change division to multiplication, and you're going to flip the second fraction. So for this first one, in my numerator, I have a greatest common factor of 4. So inside parentheses, I'll have x minus 8. Divided by. In my denominator, I have a greatest common factor of 4. So inside parentheses, I'll have 5x plus 8. I am going to change my division to multiplication, and I am going to flip this fraction. 5x plus 8 does not simplify, and neither does 16x squared. Now that I have kept my first fraction, changed my my division sign to multiplication, and flipped my second fraction, I can go ahead and start simplifying. 4 divided by 4 is equivalent to 1. 5x plus 8 divided by 5x plus 8 is equivalent to 1. In my numerator, I have x minus 8. And in my denominator, I have 16x squared. There is nothing left to simplify here. This is my answer. They also asked for us to find the domain. So I need to find my domain restrictions, which are the same thing as your excluded values. To do that, take your simplified form of your denominator, so everything that's factored completely, set each factor equal to 0 and solve. So I'll have 4 equals 0, 5x plus 8 equals 0, and 16x squared equals 0. 4 does not equal 0. That's a false statement. To solve the second equation, I'll subtract 8 on both sides. So I'll have 5x equals negative 8. Divide both sides by 5 and get x equals negative 8 over 5. To undo multiplication, I'll do division and get x squared equals 0. To undo a square, I'll take the square root and get x equals 0. So my domain is all values of x such that x does not equal negative 8/5 or 0. On example 7, it says divide and state the excluded values. When I look at my numerator of my first fraction, I see that there is a GCF of 3x. So when I factor that out, inside parentheses, I'll have x squared plus 2x plus 1 divided by x plus 2 in my denominator is already simplified. I'm going to change my division symbol to multiplication, and I'm going to flip the second fraction. X squared plus x has a GCF of x, and inside parentheses that will leave me with x plus 1. X plus 2 does not factor any more than it's already factored. My denominator is factored completely, so this is a good time to find my excluded values. Again, your excluded values are the same thing as your domain restrictions. And so I'm going to set each factor equal to 0 and solve. To undo addition, I'll do subtraction and get x equals negative 2. Here, x equals 0 is already solved for. And for this last one, I'll get x equals negative 1. So my domain is going to be all values of x such that x does not equal negative 2, 0, or negative 1. If I come back over here to my fraction, I can simplify this a little bit more. This, we actually already factored this earlier. Let me scroll up to it. We factored it right here. And so x squared plus 2x plus 1 factors into x plus 1 times x plus 1. So I'm going to go ahead and use that. So I'm going to bring down the 3x. And we said that this factors into x plus 1. Let me use the same color. Don't die on me. We are almost done. So here this is x plus 1 times x plus 1. And then x plus 2, that one's already factored completely, so I'm going to bring that over. In my denominator, we have x plus 2 times x plus 1. Now let's look for common factors that can eliminate. So let's see. X plus 1 can eliminate with x plus 1. X plus 2 can eliminate with x plus 2. And x can eliminate with x. So all that's left in my numerator is 3 times x plus 1. And in my denominator, everything eliminated because they were equivalent to 1. So all that's left in my denominator is 1. So 3 times x plus 1 divided by 1 is the same thing as 3 times x plus 1. This is my answer. If you wanted, you could write your answer as 3x plus 3 if you want to distribute. It is not required. That step is up to you and whatever feels right to you and your brain. That is simplifying, multiplying, and dividing rational expressions.